The following presentation is about graphing radical functions. Let's say we have the function f of x is equal to the square root of x. In order to graph this function, I need a table of values. We're going to be very careful about the values that we plug into the square root of x because we cannot square root negative numbers, and we're also going to want to choose perfect squares for x so we avoid decimals. The smallest perfect square I have is 0. Square root of 0 is 0. The next perfect square I have is 1, followed by 4, 9, 16, and again, we found our y values by taking the square root of our x values. When I plot my function and connect them with a curve, I get something like this. Radical functions look like half of a parabola turned on its side. Now the domain and the range of our square root of x, the domain is going to be all x values greater than or equal to 0 since we can't square root a negative. And our range is going to be y is greater than or equal to 0 because all of the outputs were positive. Something you need to pay attention to is on the right side of our graph, since x and y are greater than or equal to 0, we need an arrow on the right side of our graph. But the left side of our graph, there's no arrows here because x and y cannot be negative. Translating radical functions. The standard form for the radical function is f of x is equal to a square root x minus h plus k, where a changes the steepness, h is the horizontal shift, and k is the vertical shift. Let's try to graph f of x is equal to 2 square root x minus 3 plus 1. We're going to start with the parent graph, 2 square root x, so we are going to ignore the h and the k for the time being. When I make my table of values, I'm going to use the same perfect squares as I did before, 0, 1, 4, and 9. But this time, after I take the square root of each of those numbers, I'm going to multiply by 2. Now for the h and k. The graph shifts 3 units to the right and 1 unit up. So what we're going to do is we're going to add 3 to each x value and add 1 to each y value. So our final set of values are in the table below. When I plot my points and connect it in the curve, our domain and range for this specific function is x is greater than or equal to 3 and y is greater than or equal to 1. Where did I get those values? Those are the first values in the table. This will always be true as long as you follow the procedure on the previous slide. Don't forget your arrow on the right end of your function. The next graph, y equals negative 3 square root x plus 5 minus 1. The negative a is going to reflect the function, which means it's going to flip it upside down. Positive h shifts to the left, negative k shifts down. We'll start with our parent function, negative 3 square root x. Use the same x values as before, but this time after I take the square root, I'm going to multiply by negative 3. Since we are shifting to the left, I'm going to subtract 5 from all of my x values, and since we are shifting down, I'm going to subtract 1 from all of my y values. This time when I plot my curve, we are reflected, which means we are flipped upside down. Don't forget your arrow on the right side of your function. As for the domain and the range, x is greater than negative 5 since that's the first value in my x table, but this time you have to be very careful about what's happening in the y direction. We switched it to a less than symbol because the a is negative and all of our values are below -1. So whenever you have a negative a value, you're going to use the less than symbol for your range. You can rewrite radical equations so it's easier to graph. So f of x is equal to the square root of 9x plus 18. If we factor out a 9 from our binomial, and then we can simplify that square root of 9, kick out a 3 in front of our radical symbol, we have 3 square root x plus 2. The second example, we have the square root of 16x minus 48, and that 5 is added at the back of the square root symbol. Common factor between 16 and 48 is 16. Square root of 16 is 4. We have 4 times the square root of x minus 3 plus 5. So what I want you to do now is I want you to press pause, graph both the functions, and label the domain and range. I will show you what the graphs look like on the next slide. And here we have 3 times the square root of x plus 2. The domain is x is greater than -2. The range is y is greater than 0. And 4 radical x minus 3 plus 5. The domain is greater than, x is greater than or equal to 3, and y is greater than or equal to 5.